Introduction. For this quarter's project, we'll be presenting about the sonic boom. There are shock waves that are produced by an aircraft or other objects that are flying at a speed equal to or exceeding the speed of sound that is heard underground as a sound like a clap of thunder. Basic concepts. The basic concepts we'll be covering in this presentation is the Mach number, the travel of sound waves, constructive and destructive interference, and our perception of sound.
Mach number is a ratio of the speed of a sound in air to the speed of an object. This number is applied in aerodynamics to predict and calculate for the various properties of air and aircraft. Because the speed of sound in the air varies with temperature and altitude, the speed of sound has to be measured at the object in order to get the accurate Mach number. There can be multiple different conditions in which the Mach number is the same while the true speed of the object are different. Mach number would then be determined whether or not a sonic boom would be created.
Sound wave travel. Sound is created by waves of pressure in a medium, caused by particles colliding with other particles in a chain. The peaks and troughs of the waves are represented by areas of high pressure and low pressure, called compression and rarefaction. In a medium at a certain pressure, temperature, and humidity, sound waves travel at a set speed. If these parameters change, the speed of sound also changes.
Interference. Constructive interference is when waves overlap each other to create a larger wave, and the opposite applies to the destructive interference. In the air, the parts of these waves are compression and rarefaction, where the air is bunched together in higher pressure and spread apart in lower pressure, respectively. Areas of compression overlap to create even higher pressure. If two equal areas of compression and rarefaction overlap, the two destructively interfere and cancel out to zero. So in our supersonic example, the waves at the front constructively interfere in a cone shape to create a shock wave.
Perception. Imagine feeling the wind blow on your skin. Your ears are like that, but a million times more sensitive. Even the slightest changes in air pressure can be picked up by your ears and perceived as sound. By knowing that, your ears pick up the changes in pressure. We can understand that when the area of high pressure passes our ears, we receive a loud boom.
When you hear a supersonic plane go by, you might notice that there aren't just one boom, but two. But why? If we remember that sound is perceived when our ears notice a change in pressure, we can further understand that the two booms come from when the pressure suddenly increases and decreases. As shown in the picture on the right, in front of the aircraft and directly behind it is an atmospheric pressure. In the between the two yellow lines is the area of high pressure. The first boom is heard when the rightmost yellow line passes the observer, and the second is when the leftmost yellow line passes the observer.
As previously stated, Mach numbers are the ratios of the speed of sound in air to the speed of an object. There are many ranges to Mach numbers. It can be below Mach 1, equivalent to it, or above Mach 1. An example of below Mach 1, an aircraft in flight creates a series of pressure waves that travels outward in all directions. For Mach 1, the faster the aircraft moves, the more compressed the waves become. For above Mach 1, the waves merge into a shock wave due to supersonic speeds. The pressure field is confined to a region extending mostly to the rear and extending from the craft in a restricted widening cone, called a Mach cone, resulting in a sonic boom, which could be heard by a person if it crosses their location.
Thank you for listening, and that's the end.